In this video, I'm going to be showing you how to use MindStudio to build an AI worker that performs data analysis using dynamically generated code based on the data and the user's query. So if you've seen things like OpenAI's code interpreter or other products like that, this is basically how to build out that same pattern in MindStudio. So just to get started, I found this random, CSV of US states and population density by age. And I downloaded it, and we can see that it's just this, CSV. It's got some extra rows and headers. It's got some weird notes at the bottom. So it's not something that we could just, it's not just a matter of splitting kind of line by line. We also need to take care to notice the column headers and then trim off any extra data. So if you were writing JavaScript to do this, like, it would be pretty straightforward to look at this and write a simple function that, parses it into whatever format you want to work with. The value, however, of this more dynamic approach is that you're not locked into a single schema in the way that you are with code. So if this format changed, or if you had one that was, maybe it was county level data or country level data, or had different buckets, or, different header, different schema, the value of generating the code dynamically in response to the data that you're analyzing is that we can adjust to these things on the fly and still get the correct output. So I've downloaded that, and I've built out this workflow here that has a couple steps. So the first step is to download the CSV from the URL that it lives at, or you could, pass it as an argument in an API call. Kind of up to you how you want to get it into MindStudio. That's basically, what this step does, is get the data into MindStudio. And then there's a step that we're doing before we actually generate the code to perform the analysis, which I actually found in testing was really important. So if we go over here, and you can actually expand these things out full screen now into tabs, which is pretty cool. Basically, what we're asking it to do before it writes the code is there's almost kind of two personas in this workflow. And the first one, think of it like the boss who is saying, hey, engineer, I need you to write this function that analyzes this CSV. And they're a good boss, so they wrote out a really detailed spec that makes it as clear and unambiguous and straightforward as possible for the engineer to sit and write the code. The engineer doesn't need to know anything about, the customer's ask. In our case, we're the customer, our query, or kind of why they're doing it, or what the data is, or whatever. Just, using the spec, they should be able to build out the code. So to do this, we make use of a few things. The first is the general kind of instructions asking the LLM, in this case, Claude 3.5 Sonnet, to create a high-level plan for evaluating the user's request and turning it into code. And then what we provide down here, and this is using some new kind of handlebars functions, which are a little odd to me in terms of formatting, but this is the handlebars, spec convention. So basically allowing you to sample, in this case, the variable input, which is what this download CSV block outputs, to create a sample of the first 20 lines and then the last 20 lines. And this as a pattern seemed to work well because, again, like just looking at the first 20 lines here, you'd be like, okay, there's a header and then there's just states. What you wouldn't see is all this garbage down here that it needs to be able to process. So by including kind of the tail end of the file as well, it's able to get a better sense of the shape and structure of the data. And because we're only returning, 40 lines here, this is actually manageable as an LLM inference call. It's not, overly expensive or time consuming or pricey or anything like that. So we're providing the sample and we're asking it to write a plan that it can give to a junior developer and have them implement with no ambiguity or errors. We also ask it to include relevant data structures, places where there might be obvious mistakes. And then it's hilarious that you have to keep doing this with these things, but just keep reminding it not to write code that has bugs in it. That honestly seems to have an effect, which is very silly to me, but here we are. And then it's going to return the spec and save it as this variable called input. Oh, sorry. I'm clicking on the wrong block here. It's going to save it as this variable called function spec. And then it's going to actually transition into this block where we generate the code. And if I go ahead and pop this open, these are the instructions that basically, include the same query, give it some more kind of precise instructions. I had to give it kind of how I wanted the function signature to begin. Otherwise, I found that it, seemed a little overeager to give it its own names for things, and I didn't want that. The same sample of the 20 beginning and end lines of the file, and then the spec that the block before wrote for it. And then we're going to save this to a variable called code. And then we pass that into this execute code block, which I'll go into in a second. And that runs the generated code from this block. And then we, in this case, display the output. We could have a generate text block here that, transformed it into a nice markdown table, or parsed it as JSON, or, some API call to generate a chart, something like that. Here we're just ending with the result, and that ends the workflow. So let me click into these two blocks, and I'll just quickly show you what's happening. In the download ones, you can see, how straightforward it is here. This is the whole block. So it's getting basically a property called URL. So we define URL over here, which is one of our launch variables. And we define that the output of this goes into a variable called input. So it's getting the URL, downloading the URL, and then saving the URL as a variable. And that's this whole function. And then the execute code block is also deceptively simple. So it's getting the input, which in this case is the raw CSV that we downloaded from the download block that we just looked at. And then the value of the code variable, which is what the previous block just generated, the JavaScript function. And we're just calling eval on it. Pretty straightforward to basically just run one of these things in here. And then we're saving the result. And that is really all there is to it. I used an auto-generated system prompt here that it's, JavaScript expert who generates modern ES6 code functions to help perform specific data analysis on a CSV file. This is kind of just general grounding for the thing. And then, I also used the profile here the profiler here to kind of test out different models, which was important in finding that, this Claude one actually wrote better code than GPT did. And when we run one of these, I'll come back here and we can see the result here. So these are my 3 evaluations that I made. It's the same URL for that CSV that I just re-uploaded somewhere convenient. And then the query is the thing that I'm going to ask it for. So again, if we go back to this, we can see it's US states and then population as a number in these age buckets here. And so in this first one, I'm asking it for the percentage of each population group across all states. And I'm also asking it to include a checksum at the end to make sure that the percentages all add up to 100%. In this one, just the sum of each population group across all states. And then in this one, a little more specific, the total number of just adults ages 19 to 25. So if we go ahead and run all of these, and I'm going to let this run here, it's going to take a moment, and we should hopefully see some results. And then we can go into the debugger and actually look at some of the logs and see what it did. Okay, so we've now got our results in here. As we can see, this one generated percentages that add up to 100 with this checksum. This one returned all of the sums, and this one just returned a total value. And we can see right here, actually, that these two match, so we can verify that. And then if we go into the debugger here, we can see these. Let's look at the first one. So this is the one asking for the sums of each of the bins and then cast that as a percentage and include a checksum. So we got the query and we got the URL. And then we run the first custom function, which downloads the file. So you can see downloading file here. And then this is the raw content of the CSV that we can expand out if we want to. And then we send this next message, which if we look at the resolved version, returns the first 20 lines and then the last 20 lines and asks it to generate the plan. And then we get back this plan, specification for population percentage calculator. And it includes a section on data pre-processing, to skip the metadata, to skip the footers, to remove strings to integers. It creates, I found this to be really valuable, is it creates basically the desired result data structure. That seemed to be very helpful in getting it to write code that made sense. And then the calculation, error handling, validation, return format, and then some nice potential pitfalls to address, which is good because, again, like even if we might take these things for granted, it's nice to just remind it. Also, I love that there's some footnote in here that is just like no to Puerto Rico. And then, so after that, actually, let's quickly bring this into the profiler here. So we can see the difference between, in this case, GPT-4o and Claude 3.5 Sonnet, and the ways in which it generates different plans for these different things. And you can see why I personally, in building this, decided to go with Claude 3.5 Sonnet. So GPT, I think, did fine. Like, I think both of these would probably work fine. This one specifically tended to prefer including a return format as an object, and I liked that, so went with that. A little bit slower, but I think that's okay because, you know, these sorts of tasks, generally we anticipate them running as kind of scheduled jobs or background workers or webhooks or automations or things like that. So, you know, they're not meant for you to be kind of sitting there waiting for it to spin and watching it. So I didn't care in this case. If I had a more kind of time-sensitive use case where I wanted the user to sit and, you know, do this manually, maybe I'd prefer something that's a little speedier. Anyway, let's go back to this. We get the plan, and then we use the plan alongside the CSV data to generate the actual code. So we can see it all. And then we can see the code that it did here. I don't even know what BOM is. Some kind of weird text encoding thing, but like great that it did that. And then find the header row and replace it, build out the result set, process all the rows. Again, skip Puerto Rico. So it cares about these edge cases. So that's cool to see that it's not, you know, it's not just generating like I could probably make a 1 or 2 liner out of this. And, you know, before I introduced this create plan step, if I just had to go straight into generating code, you often got back kind of like a stereotypical 5-line Stack Overflow function that's just like, you know, CSV string dot split dot filter dot trim dot join, whatever. Giving it the plan actually, I think, coerces it into writing something a little more verbose and more likely to be correct. It's not trying to do anything clever here. It's just being boring and straightforward. And then we execute the function in MindStudio's JavaScript execution environment, and we get back the result, and then we save it. And then, you know, if I weren't on a demo account where everything is free, you would be able to see the full cost of this thing. And we get this for, you know, these other ones. So the sum of each population group across all states. So we can see with this one that, you know, the plan that it made is different. And actually, let's see, the code is probably, different here. Yeah, see, it initializes these groups into an array and then turns them into an object and then goes through it that way. Is this how I would do it? Probably not, but it works, and that's awesome. And here's the result. And let's see this last one, which is just the sum. And we can see, again, a different plan came out of this, and different code came out of this. So this one's a little more straightforward because it's only looking for one specific column and returning one specific sum value. And here, let's go ahead and we can also see just quickly in the profiler. So this is the generate code step, and we can again test the difference between the two models here. So, again, Claude, a little more verbose. There's a lot going on in what GPT-4o is spitting out here. Not to say it wouldn't work, but I personally, especially for data analysis where, it's much more iterative, it doesn't need to be highly optimized in, most of these sorts of reporting type cases. I prefer the much more verbose and straightforward way of doing it. And let's actually just, for fun here, see what, let's throw a couple more. Let's throw Gemini 1.5 Pro in here. And let's throw, we were using 4.0 and we were being mean to it. Let's see what GPT-4 Turbo has to say here. And we'll go back and bring our code in here. And now let's see what we get back. See, this guy's really going. I think all of these would probably be fine. You'd have to try it and see and play with it. And you could probably ask them to be a little more verbose and include comments and, not do any sort of like these, extra long, whatever, map, trim, replace, reduce, all of that, like kind of break it up a bit. I think that's the fun of building this stuff with MindStudio is you get to, see all of these different things side by side and play with them and build out kind of the best thing for your use case. Because one of the issues with anyone who has used these sorts of code interpreter type things in real production environments with real data is that they can be kind of fragile. And if they break in weird ways. And, that might be fine if you are using them as an assistant or a co-pilot as part of a chat session to explore a document because you can, take a step back and ask a query differently or try and get it to correct or nudge it or whatever. It means you can't rely on them for automated workflows though. And, maybe someday we'll get to the point where there's a big one-size-fits-all thing that does all of this. But for right now, you can build this and launch this today and start using it with your data. The value comes kind of in this sweet spot between, like, if you know the structure of your data, if it's consistent, if all you wanted to do was parse a CSV that had these columns and these rows, like you could just write a JavaScript function to do that. Or you could, use one of these LLMs to write the JavaScript function once and then paste it into this execute code block and just have it run. And that would be much faster and more cost efficient. Similarly, on the other end, if you have completely arbitrary needs and you want to parse arbitrary things in arbitrary ways, like you probably do want to do that in kind of a more hand-holdy, iterative chat session type experience because it is going to be much more fragile and much less reliable. And you might get the output, but it's going to take a little while to work it there. Where this comes in handy is when you generally know what the data is and generally know what it is you want of it. Things that have kind of similar shapes and smells, even if they're not exactly the same kind of at a schema level. That's where this sort of approach really shines. And, this is a very kind of straightforward and simple demo, but you can totally push it in terms of these queries. You can combine multiple inputs, multiple data sources. You can mix and match across things. You can generate visualizations. You can, kind of imagination is the limit here. And when you have this level of granular control over the process, you can start to build really amazing things and really reliable and dependable and robust things that you can integrate into workflows. I hope this was interesting. I will make this project available to be cloned, to be remixed, so you can play around with it. And yeah, excited to see what you built.